running with voice. All right, so today we have two speakers and one event. And one of the guys from Microsoft, Hayakawa-san, will explain the garbage collection for .NET. And Jim will be talking about the concurrency by actor. I don't remember everything, but he explained that. And we also have the coding challenges for the group. So we have two groups. So left side, right side. And I give you the spec so that you guys try to collaborate each other to creating the perfect application. And at the end of the session, you guys comes up in front to showing what you got. Okay? Make sense?
How can I mute hang up? Hang up.
So you don't have to mute hang up?
Yeah.
You should be able to.
I can only mute my computer.
You can mute your computer.
Yeah, but then I can't check.
Let me wait. He said it's muted.
No, I'm muted. But
Yep.
I don't want to hear it from here.
Right. You can mute entire. Well, what? Why is that? Oh, you don't know how to mute. Right here is mute the YouTube.
I can mute YouTube, but I want to check YouTube. This is coming with audio.
Yeah.
I have two audios.
Right.
Other than hang up.
Well, maybe you can just simply close in YouTube. You shouldn't close it.
How can I check YouTube?
All right, because you already checked that.
But I'm just checking now for you.
Yeah. All right, so Happy New Year, guys. I feel a bit sorry that we have way less people than usual. Maybe people are very busy on the past month of the year. But the good news is you can get way more pizza than usual. So just try to eat all the pizza. We have 4 L-size pizza. And today we have very interesting guest from the New Caledonia, right? Am I right? New Caledonia. And Julian, the SharePoint MVP, he is just visiting Japan. And interestingly, I met him in Hibiya Park on Sunday for my street workout. And one of the guys, he also come to .NET Developer Meetup sometimes. Flo is his friend. So I see him, and Flo introduced him to me. He's the MVP, the SharePoint. So I said, why not you're coming to the .NET Developer Meetup to hopefully give some presentation, but obviously he's on vacation. He didn't have enough time to prepare. So today he's just joining us at the but I welcome you.
Why didn't you just tell him yesterday? Oh, both of us. He was already here.
We get used to. We are not on vacation, right? All right, so I hand to the Hayakawa-san.
He's correct.
Yeah, of course. これとこれね。So, hello, my name is Hiroyuki, and I'd like to talk about garbage collection. And you all may know well about that, but this is relearning. So it would be nice if you feel relaxed. And if you have any question, please let me know anytime. So let's get started. Here's the words. C++ is my favorite garbage collected language. Do you know who say that? Because it generates so little garbage. He said. So at first, I'd like to introduce myself in shortly. I'm at Microsoft 10 years, and I'm supporting Visual Studio and .NET Framework and C++ developer tools. So last year and 2 years ago, I attended Decode, the Microsoft events, and for the seminar. So if you have interested in it, please check this video later. It is debugging things. So today's I'd like to talk about the memory management of CLR and the garbage collection algorithm and finalization and typical issues. Looks fun?
Yes.
Thank you. At first, I'd like to talk about memory management. CLR, the .NET Common Language Runtime, is the core component of .NET Framework. And memory management by garbage collector is one of the most important functionality of CLR. So other functionalities are like this, but memory management is most important. In .NET Framework, the lifetime of objects are fully managed by garbage collector. There are no ways to release manage object other than GC. So GC reduces this common programming errors such as memory leaks, double freeze, and dangling pointers. Yeah. Also, CLR uses mark and sweep generational GC. So this is the overview of the generational garbage collection. At first, there are only generation 0, and there are objects used by applications. Then, if CLR runs the GC, if it's determine it needed. After that, generation 1 is generated and look like this. After that, second GC runs, Gen 0 appears, and there are 3 generations like this. This is another figure. Initial state, there are generation 0, and this bar expressed a segment of the ephemeral segment, which means the in use of short-term memory allocation. The initial state is like that, and after the first GC, it would be this, and that second GC happens. The segment is separated as below. The next, if the many GC happens, the segment is added like this, and the additional segment is used for the generation 2 or long. Gen 0 and Gen 1 don't use this additional segment. And if the more GC happens, it would be like this.
But,
Okay.
Yeah, sure, of course.
I'm sorry, I'm really new to calculation.
Okay.
So, could you explain what does the blue area mean and what does the orange area mean?
Okay.
Memory.
Yeah. The blue area is occupied by objects. Yeah.
So, Gen 0 means the existing object on it.
Yes.
And the orange is the free area.
Yes.
And the generation means each time on garbage collection, the new equated object will be put in the separate segment.
Mm-hmm.
Is that correct?
Yes.
Or it's more like with the object on the generation 0, when the garbage collection is running, if it survived, it's going to generation 1.
Oh, it will be migrated.
So object will be migrated.
Migrated object sit in generation 0, and if it survives generation 1 to the garbage collection, it promotes to generation 1.
So it's being actively used at the time the garbage collection runs. It does not get cleaned up, it goes to the next generation.
So even the existing object we migrated into generation 1, it still stays in generation 0.
Only if it's still being used.
Okay.
You create a variable like a for loop really fast. You stop using it. Next time garbage collection, it removes it. But a variable that you keep for a long time will eventually migrate generation 1 to generation 2.
Okay, thank you. And here is a picture of the image of heap, and there are 3 objects, and there is a pointer which indicates the last object address, and you should use this address to allocate next object, and there are continuous areas. So if GC needs to allocate the object, it doesn't need to merge or making a large space to allocate the object. It can just put the object in this area. So the memory allocation of CRR is faster than C++ or other language. So what causes GC? The one is the memory allocation, and the generational threshold reached. It means the image there are 4 objects occupied in generation 0, and application requires another object to allocate. And that time there are no room for allocate. So GC decide to run garbage collection. And we also call DC correct API to post DC. Okay. Also, the system-wide memory pressure can cause the GC, but it is really rare. So you don't need to think about that. And we have 2 types of GC. The one is workstation GC, and the other is server GC. And the default setting is workstation GC in .NET. Also, web applications specify the server GC in the config file like that. So web application, SP.NET also runs under the server GC setting. And server GC is optimized for the throughput of garbage collection. On the other hand, the workstation GC is optimized for minimal lag, or keep it responsive. And once GC happens, it may cause the unresponsive time, but workstation GC is try to shorten the time of not responding. So next, this is a picture of the. Also, we have background GC functionalities. I mean, there is background workstation GC and background server GC. Background means the working in background. And in this picture, the blue arrow expresses the suspend of the threads, each thread. So the long blue arrow means the long termination of the thread. So the background server GC tries to work in background and try to shorten the unresponsive time. And also, we can disable this behavior by setting this config file. So if we disable it, it will be like this. And when GC works, the threads which process the application logic may suspend it. So it cannot respond to outside, like user interface or the communication things. So you can choose which flavor is suitable for your application. So I'd like to introduce the garbage collection algorithm next. There is a concept of root. Root means the root, and each object generated by new in C#, it is associated with some kind of root at first. The root could be a static field defined within a type, or a parameter of each method, or local variables and CPU registers. So next, this is the flow of the garbage collection. At first, DC tried to suspend all threads to execute GC in safe way. And then there is a mark phase. The mark phase means looking for the objects which are no longer associated with the root I mentioned earlier. And next, the plan phase. Sorry. In plan phase, it creates a generational budget to determine fragmentation. It means that prepare for the next actual object removing or compaction. So next, they sweep the object which is no longer needed. And next, the GC do the compaction. Memory compaction means that fix the sparse of memory area. If it's okay, this makes sense. And then reset the threads. Next, there's finalization. GC knows about only about the manage object, which is generated by the new statement of C#. And however, there are objects that wrap the native type resources, such as Windows handles, Windows native handles, or native connections. So GC can't clean up them by itself. So such kind of object needs to some system to release it. Then such object has to have the functionality of finalizer or implement iDisposable interface. So I'd like to show the flow of finalization. There's an object from A to J, And this arrow means the root difference. This is the root thing, and these objects are referenced by root, so these should be survived in the next garbage collection. And also there are finalization queue inside. And the object which has a finalized method, which is similar to the destructor of C++, is automatically listed in this queue. So in this situation, the CEFIJ has a finalized method. And then, if the GC runs, these objects should be removed. But the object listed in here has the finalized method. So GC tries to call these finalized methods in a certain way. So actually, it's use this queue, another queue. It is called as a reachable queue. And the object, which can be free in the point of view of manage, is copied to this reachable queue and make a difference from this copy to actual object. So now this has a new reference. So it is no longer the target of the garbage collection at this moment. So this object is once regarded as no needed, but at this moment it is different. It's a bit interesting. So next time, at this moment, objects are survived, and finalizer calls the finalized method of these objects. Then they are no needed at least, at last. Then these objects are free, and objects become like this. So this is why we need to call this correct at least twice to clean up the object perfectly. So many characters. Even if you don't clean up the object by calling this pose, finalizer thread is part of GC. Thread calls its finalized method during GC. So, however, the native resources such as the database connections or native memories should be cleaned up as soon as possible if it is no longer needed. So consider using this pose pattern and using keywords so that the iDisposable object is automatically cleaned up if it goes out of scope. Yeah. So please consider using these methods and statements. So I'd like to show some typical issues. The finalized thread can hang up and stop its work. So it can be cause it could cause the memory leak. It can happen the invoking con method from finalized thread to STA thread. So if you use the com object in .NET application, and if you see the memory leak, you can suspect this situation. So
you're still using STA, your hair is probably all gray by there.
And also, it is similar, but GC doesn't happen so often since the managed heap is not full. However, some native resource wrapped by the managed object can acquire a big resource. So in that situation, since GC doesn't occur so often, the native code is finalized method is not called, so the native resource can be leaked, such as GDI object or user object, and it can be reached to its limitation. It tends to take place with the application running on multi-core processor with server GC, because the multi-core application run on the multi-core processor with server GC can have huge managed segment. So tends to not happen GC so often. But this situation could be resolved by the timely dispose or using statement. Also, there are performance degradation caused by the frequent GC. In most cases, performance issue comes from GC of generation 2 or LOH. LOH means the large object heap. It is similar to generation 2, but I didn't explain about that, but it is a similar one. So you may need to identify which object occupies GC heap, and you can use this is debugger command, ban SOS that dump heap and -stat or some other command. If they are remaining unexpectedly, you need to identify the reason. And for that, you can use the ban.sos.gc root command in the debugger, like WinDBG. Also, if they are not unexpected, you need to review the design of your application. Consider allocating large object in early time of the process so that it can avoid fragmentation of large object heap. Also, the pinning of the object also can be the cause of fragmentation. That's all. Actually, this is the part of training material for my colleague in India. So I shortened that, and it might be not clear for you to understand. But
Any question?
Any question?
Right. Just one small question. You said in the middle something interesting to me, that the system-wide memory pressure can trigger a garbage collection, but you don't have to worry about it because it's unusual. Is that true even for platforms like .NET Core and Raspberry Pi or Xamarin iOS and other memory-constrained environments, or would the system-wide pressure on those systems cause more frequent garbage collections?
Yeah, it can cause, but I guess in such small platform, the GC can occur more often caused by the other reason. Yeah. Yeah, it can occur.
Any other question? Thank you.
Thank you.
And luckily enough, we do not have too much people in this room today. So I would like to do some exercise about garbage collecting ourselves. So could you,
garbage.
yeah, could you go to the side to grab a dish, please. Every one of you. Go to the side, grab a dish. If you already have a dish, that's okay. But still, please go to the side and don't eat pizza at this moment because we need pizza for this workshop. And this is a good opportunity to fully understand what the garbage collection does. So imagine I am a garbage collection thread. I'm the one to do the garbage collection. So everybody have dish, right? And don't eat pizza. And pick up the pizza, pick up pizza, and put pizza on your table, on your dish. And once you put it, bring it to me. So pick up pizza and come into my place.
Selected directly into his mouth.
Yeah. Then come to the front. Come to the front.
Can I be
Hey, Julian, you need the dish and the pizza. Don't worry, I don't eat.
I'm the
So imagine,
Yeah.
this area. I created this area. This is a heap of the memory space so that I can store in your object. And you creating a new object, right? So I store your object here, right? Remember, this is yours.
Yeah.
Okay? And give me yours. So this is another object comes in. And another object comes in. Just please remember which one is yours, okay? So you are the root. You guys are root of each object, okay? So this is rooted to Julian. This is rooted to Shaw, something like that. This is rooted to you, okay? Right, so give me the new object. This is a new instance of the pizza. All right, new pizza, I take away. New pizza.
Mine's disposed.
No, not yet. Not yet. New pizza and new pizza. All right, so I have a heap with object, and Julia, maybe is yours.
Yeah.
Could you eat up?
Sure.
To free the space?
Everything?
Yeah.
Yeah, just put the
So
whole thing in your
now
mouth.
it's a garbage collection time. So I comes in to see which one is still rooted or not. This is still using, right, by somebody. This is still using, so I cannot throw it away. But this one, I can throw it away, right? But now I want you guys to stop working because, so this is for Julian. But if I remove this, and then if I keep as it is, no issue, right? So who is this one? So if you come in to pick up your pizza, you still know where it is, right?
Yeah.
But I want to, this is a sweep process, and I want to compact the table because I want to keep adding, right? But if I compact this one, like that, now your pizza address is now changing.
Yes.
That's why I need you all to freeze. Don't try to come at this moment to take up your pizza because you may pick up some wrong pizza. This is a big issue, right? But while I'm doing the compaction, everybody is stopping. The application is holding, right? Now I completed my compaction. So go ahead. So who is this one?
Mine.
All right, so please eat. You just take it.
Picking up the wrong pizza is
Yeah, take up the wrong pizza is a big issue, right? Now, at the garbage collection time, I come in to check which are free. But the issue is, this was not free before. This is second time to check. This is also second time check, right? And I don't want to keep checking if it keep using. And how to avoid checking every time. The way is promoting this guy to generation 1. So that I only work generation 1, less time to generation 0. So this is generation 0. This is generation 1. So this guy survived this time. All right, this guy also surviving. Survive. All right, so I free up my gen 0 and now pick up a new pizza. Pick up a new pizza, please.
It's yours.
Yeah, but we need a new pizza.
Which one do you
Somebody? Yeah. Do you guys still remember which one is yours? You should.
Should we be videoing this for YouTube?
Yeah, sure. Now I got a new object, so I put in the gen 0. So this is how garbage collector managing to keep by generation 0 to generation 1. The reason why we want to put generation 0 to generation 1 is because I want to check less for this one, because I already checked several times. Actually, right after the first check, we are moving to generation 1 though. Right? So this is one way. The another way is, so let's imagine this pizza coming from the shisha, but this potato coming from somewhere else, native, right? So who is this one? This one? Yes. So just take the pizza. Just take the pizza. Yeah, yours?
No, it's you.
James? Okay, James, take the pizza. Only pizza, not potato. Only pizza. Just a pizza, right? So this is supposed to be free, but there is a potato, right? But I have no idea how to free that potato. So even though I can say I can free this up, I still do not know how to take care of the potato. So I'm putting this aside so that somebody else can take a special care. And if you take special care, of course, the guy writing the code should know how to dispose this one, right? So that's a finite queue, right? Something like that. Got it? All right, the workshop done, and please pick up your appropriate pizza and eat up. So this is a good way for me to clean up pizzas. Thank you. Thank you. We take 5 minutes break, and after that, so Jamie, do you want to do the presentation, or do we want to jump into the team challenge?
I don't think we have time for both. 38.
Maybe we may want to jump into the teamwork then, if you don't mind.
Are you still sharing that screen over there?
Yeah, I'm sharing.
I should have been sharing my screen to show the pizza on YouTube.
Right, so I'm sharing the meetup.com. So the session review will start in 5 minutes. So take rest, please. The restroom outside, the free drink outside, Wi-Fi code in front, free pizza still remaining. You can renew the new pizza.
I hit the wrong pizza. Someone house of P invoke.
That's the
Yeah. So P invoke is gonna remember the wrong pizza for its callback.
Yeah. And finally, you can new reference.
But I found
the pizza, Japanese pizza time. Okay, dominant pizza, but might be something different.
everything.
Everything different? How different that?
Well, first of all, the toppings are all weird.
Oh, really? Okay, I didn't know that. So are you comparing with the United States?
Yeah.
So you're saying Japanese wine is weird or yours is weird?
Well, it depends on the perspective, I guess. Relativity says we're both correct.
Yeah.
And they're both weird.
Yeah. So pizza, we're supposed to put everything we want to put, right? That's a pizza, right?
Yeah. But, you know, if you go to Italy and
That's totally different.
and you put on a pineapple on the pizza, they're going to murder you.
Yeah. The only thing you can put in the Italy is the tomato and the cheese, right?
Margarita.
Margarita. Okay.
They did a prank on YouTube.
Yeah.
They had the old Italian people from the city where margarita is popular. They ordered the margarita pizza and they brought them the Hawaiian pizza instead. They were shouting and screaming, saying, "Get out of here before I punch you!" I'd throw that pizza down the stairs.
What's this pineapple coming from?
It's really fun. Yeah. No, sorry. Actually, here's the middle one. It's just like sushi. Many kinds of sushi in Japan, but then you go to America, there's many more weird ones.
Yeah, California roll.
But now California roll is getting popular in Japan.
Yeah, sure. One American round Sweden.
Yeah.
All right, so it's time to team up. So team A on the left side, and team B, or team A, team Z on the right side. So could you please pick up one PC so that you guys can work together? And I recommend you guys to rotating the program if you want. And others just watching also should contribute in some way. All right?
I'm going to delete everything. That's my contribution. I'm going to delete everything.
And I give you what you want to do now.
Yeah, but I don't teach you.
All right, so today, I give you 30 minutes. After the 30 minutes, each of you coming in front to explain what you have done, okay? And today, what we are creating is this called Pelmanism. It's more like a memory game. So imagine you have 10 trump cards, like 1 to 5, spade and heart. So 1, ace of spade, 2 of spade, 3 of spade, 4 of spade, 5 of spade, and ace of heart, 2 of heart, 3 of heart, 4 of heart, 5 of heart, 10 cards. And you shuffle them and you just flip to the background. And the first player pick 2 cards to see if the number match. If match, you can take it. Otherwise, come over to the other guy. Other guy also pick up 2 cards. So that's the game, right? You know the game, right? In the in case you Japanese Japanese. So I hope you know the game. So today I want you to creating this game, and so this is how it works. So make group with at least 3 people. So we have 4 people in each group, and write some code which actually working, and shows the progress at the end. The reason why I said progress, meaning you don't have to complete. I wish you can complete, but you don't have to. Or in other way, even though you don't complete, you still need to showing what you have done, okay? Then this is a spec. So you have 10 trump cards, spades 1 to 5, and the heart 1 to 5. If you prefer crab, go ahead to use crab. And they should be placed randomly. So imagine you have 10 cards, and 10 cards have to randomly place. You don't have to. You cannot place 1 to 5, okay? Random. Every time random. I can say in English. Randomize, yeah, you have to randomize every time. And you need to place 5 cards in a row, and you have to create 2 rows. So 1 row, 5 cards, and the second row, 5 cards, so that the player can pick up a card by specifying row number and the column number. Make sense? So I don't want you to place 10 cards in a row. 5 in a row, and another 5 in the second row. Okay? And basically, we have 2 players, so you have to identify which is which first player and second player. And a player pick up card 1 by 1, so one player can pick up 2 cards, of course. And a player cannot pick up card if the card is already taken. So imagine if somebody already matching the card, if there is no card on that place, and if another player tries to pick up the card, which cannot be possible, right? So don't compact. So just keep the card as it is, but you cannot pick up the same card again. And show the results at the end which player won. And if user try to pick up the card which is not available, let the player the pick again. Meaning, if I try to pick up some card which is not available already, taken by other player, I still keep continuing. It's not the end of my turn. So you just may be saying, hey, there is no card on the place, just pick up the one, okay? Then, even if player pick up the card which has the same value, card should be changed to another player. So you cannot keep picking up the card, even though if I match the card, pass of the ace of the spade and ace of the heart, but now I need to pass a turn to the other guy. Because in some rules, if you match the card, you can keep picking up the card. But this time, no. Every time, regardless you match or not, turn to the other one. Or that's a spec. Any question?
The player computer, but it is automatically gaming or.
Sorry, sir. So you can design. I don't have to say this should be play on the same computer. It could be the same computer, could be different computer, could be web application, could be console application, anything you want. Could be SharePoint application if you want. So just pick up any framework as long as it's meeting these specifications. Okay, any other question? All right, so go ahead to develop some interesting game. And I just put up one limitation, use .NET. It's .NET developer meetup. I don't want to see Python, I don't want to see Java. But I don't say C#, so if you want to use F#, yeah, go ahead. All right, so 30 minutes, and after 30 minutes, I ask team A to present their solution first, and team B to present their solution, and finally, I try to present my solution. So which PC are you using? Okay. If you're using this one, it's going to be .NET 4. Okay. Which PC you're using? Okay. And are you guys using C#? C#? Maybe .NET. And I'm sorry for the YouTube. This might be very boring YouTube streaming video because nothing happening on the screen. Yeah, but if you're watching the now or later, just try writing your own code and give me the GitHub address.
Can you add the specification again on the screen, please?
Sure, of course.
Yes.
What is the name? So if you have any questions, let me know.
But if it, the two cars has defined value, I'm really just reading.
Yeah.
Yeah.
Okay, that's normal.
If you can see an array,
Okay, so it's a blind.
two-dimensional array.
Or
It doesn't even matter if it's two-dimensional.
what about showing a one-dimensional array? Or randomized array?
So it may be cool to have a deck open underline that. Just
Another way of randomized having to deal with the, well, they already laid out finding files and be.
Yeah, they're all laid out in handing memory. Just might have it to make everything sealed in.
that's the
Right. I'm wondering if there's a. Workshop it, and then it's already existing on the link or something. Yeah.
Or you can have just like boolean and like forms and parts and strings. Yeah. Yeah. Just send it. So that's cool.
In this game.
Not entirely how to run it. E-direction.
And when you make it,
It's system cards. That's not. We should have. Just do a folder. Like one, group one, part. What we should.
I did that.
I like the two ceremony. One to five. Just this copy to get first. All the cards and like. What about actually the game class? God.
It can be empty space. This is going to be a test driven game.
So, add a play class, a play function.
Yeah.
So since we're printing face down, what about printing those on A and B and then printing numbers down to 5? So when you input your 1, it's 5. Let's roll 1, 6, 4, 2, 2, 0, 3, 6. For the 4. Consider for example, 1 to 10 to 5. And we'll just find out that general do that. But someone has to now. To might be on. Or create a number from like 1 to 10. Whatever the number is, we put that in the first place of a new area where we first, and then we can do a program. I think the people wants to really comfortable to go on the box. Well, just pretty much.
It's going to print the start.
And then when you know the position, you print it actually from that.
Oh,
We print the string name. Yes. Print that on. Yeah. Yeah. Oh, you mean the final edition to do that as well.
Or better way to go.
You just print out.
that's something.
It's feeding.
Value.
Let's just cover the little bit, maybe not 30 minutes.
Print it out.
I know you can do it in C#.
Game.play and then just put it in as the first function of the play.
Oh.
I started to do something there. I didn't work like that. Oh, the.
Hard coding and coins. Oh, I guess that's you put another one, another 5.2.
The 2 factor potential limit. We got the
Just maybe we do research.
I guess
We can do the one in the area and we let you give it everything right back.
There's 2,000. Well, there's 2,000 acres.
Where for you?
Well, you pay a tank.
0. I, as long as it's greater than 0, greater than 0, I learn it's on. Zero to 9, 0, 1.
You want to continue?
Zero and I.
they separated 2 there.
Yeah. We just put it translate this up to the area. Soon, because we're incrementing ours every time, so.
By the time you get on with you see that full value. We're not just in our
I think that is just put them up.
We can actually do another.
Okay, maybe faster.
That has been used, but just turn it to. Once we continue with the area of Boolean, with a value, just turn it to.
But this is the goal.
Yeah. It's first character minus. anyone to take either.
It'll be a two-character.
Oh, right.
Hey, so get
Now,
this is the now value equals first capital minus 65.
have you got
And it's
to are going
Let's do it, yeah. Let's do this one first. One.
Okay.
Yes, bring in the character.
Why not just do minus 65? That's the character.
You can actually have to know if you can just
Oh, okay.
recap.
Yeah, so you might want to do two of them. That's fine. Minus 1.
Right. Red.
All right, 3 minutes to left. 3 minutes.
And you work out the carbon is actually very much.
Yeah, I know.
How many more minutes you need? 10? Can you stay a bit later? In that case, I give you another 10 minutes. That's the deadline. Just 10 minutes, 10 more minutes. All right, after the 10 minutes, both teams shall stop working, and team A showing the code first, and team B showing the code second.
Do the same. Normally people get like a message saying,
Just going across the top.
Yeah, this one. Yeah, 1, 2, 3, so it's
3 minutes left. Two minutes. So at least make sure you can compile the code.
Yeah, we're playing it.
I try to find.
If I
and then
validation, they were finished in the first.
I finish in 20 minutes. You may find that.
another group.
Oh, no, that's one of the specifications.
Okay.
Oh, we failed.
I put the validation.
A player pick up cards one by one. You get two at a time.
Yeah, that's okay. That's okay. No worries. That's okay. That's even handy. Because they can easily separate them out. Yeah. Yeah. Did you try to pick up the same pad?
That doesn't work. I can guarantee you.
You don't have to implement all the validation.
Yeah.
What?
It registers it as a match.
If you pick your same card twice, right?
Maybe we can fix that.
That's only 6 seconds. 5, 4, 3, 2, 1. All right, stop the coding. Hands off, hands off. Now, team A. Team A, please come in front. Team A. Yeah, bring your PC. Bring your PC and display to the monitor, and anybody can explain what you have done.
Are you still broadcasting on YouTube?
Yeah.
Oh, really?
Yeah, I do. I need to show my code at the end. But for these ones, always we do not broadcasting your screen, so just explain what you have done in like 5 minutes.
Okay, so anyone? Somebody could hold the microphone for him.
Okay.
Because he's
Mike stand.
So,
Yeah.
thank you.
It's cool.
So we design this kind of simple class, which express a card. It has a property that number and it's heart or space. It's also Boolean, and it's flipped. And it's player one means that it is open or obtained by player one. Okay. Then we initialize the cards and display the table with console to control, and this is initialize sequence, and this is display. And yes, actually, there's no randomize. And prompting to player one to yeah. At this moment, the input would be just one number. It's the index of the array, one-dimensional array. So then he picked up the card. It would be flipped. Then show table, and there is a loop, and we don't have time to implement the judgment process.
So you can take 2 cards, right?
Yeah.
You can flip 2 cards and confirm what match.
Yeah.
And if match, what happens? How to mark if that match or not?
It would be postcard would be flipped and
As you keep flipping.
yeah.
Oh, that's interesting. So once flipped and then once matched, you keep it flipped.
Yeah.
Otherwise, you flip back.
Would be false.
And if another guy tried to flip the card which already flipped, he says it's already taken.
Yes.
Oh, that's interesting. Yes.
Then all cards flipped. The game is over.
But you are tracking which player took the card, right?
Yes.
Okay.
So
Alright, cool. Very interesting.
I think it will work. It will work.
Yeah, of course.
Anything will
Yes. This flipping method is very interesting.
Oh, really?
I implemented it in a different way. More like database in my mind. Right? So, you have GUI. Player 1, player 2. And at this moment, you may want to flip it back to the legs, right?
Yeah.
Because it doesn't match.
Yeah.
All right. So player 1 keep going.
So, yes.
All right, team B. Yeah, of course.
I can show my terrible code that was not giving any job.
And which display? That HDMI?
HDMI.
Yeah. All right.
Oh, it's on this side.
And this is the microphone. Maybe one of the teammates would like to hold the microphone for Jim so that he can focusing on the talking.
No, speaking by drawing is on me, so.
Right, hold on. I gotta.
Jim, if you want to talk, you can talk.
Oh, dude,
I don't can talk.
I need to figure out how to mirror instead.
All right, let's see.
Displays. Arrangement. Here we go. Mirror.
All right.
Wow, this is huge now. All right, needs to be bigger. Okay, so this is our program. We divided everything into classes first, almost everything into classes. So we have a card class, a deck class, a game class. And when you start the program, it asks you for the player 1 name and the player 2 name, and then creates a game. So what does it do when it creates a game? Basically just records their names. Then the game has all the logic for playing inside of it. So the play, how it judges when it's over is it asks the deck if it still has available cards. Inside the deck, you use link to get any card which is available. A card is just like a plain old object that has a face value, a suit, a spade, or a heart, and whether or not it's available. It starts out available as true, and toString prints out like 1 of hearts, like 3 of spades, stuff like that. So first we print the deck to the screen, and then we get the player name and player score based on whether or not it's player 1's turn. You know, just a simple ternary operator, and prints out its player name's move with their score. Then we read, parse their move, and if the move is some garbage that we can't parse, then we do it again. And if the card is not available in the deck, either one of them, then they try again. But if they are available, they'll get the card 1 and card 2 and see if they're a match. And if they're a match, it'll put both of them false, available. And it'll inform them of what they got. And if it's a match, it'll say, congratulations, you're awesome, and increment the score. And then it'll switch turns. And then this is the end of the while loop. So once you get out, if the player 1 score is higher, then player 1 wins, player 2 wins, or it's a tie, and everybody loses. And the parse actually makes uses of C#7 features of returning tuples. So we take the move text, we enter it in the form row, column, row is letter and column is number, so like A1, then space, and then another one. Split those apart, parse each of them. The way we parse them is we try to get the integer of the second character, and we subtract A from the first one to get the numeric value. And if it's not 0 or 1, then no good. Wow, this is so tiny. So let's say
Team A. Team B. Okay, guys. Which card?
You have to pick 2 at once. We made a mistake on that part. You have to pick both the cards at the same time.
Yeah.
A1, B1.
A1, B1.
A1, B1.
Team B.
2 of hearts and 3 of hearts. Well, that's us. A2, A3. Yay, we're awesome. And they're gone from
Are
there.
you cheating?
I'm not cheating. Oh, I forgot to show you. Here, we implemented a shuffle method.
Yeah,
This card.shuffle, which is down here.
it's an extension method.
Just goes through and swaps them like bit by bit. So they are random. Next.
A4, A5.
A4, A5, 5 of hearts and 4 of hearts. We should clear the console so you can't see the previous moves. And also, if you pick the same card, you're guaranteed to win. So let's just keep doing that.
A1, B2. A1, yeah.
But now we have an odd number of cards left, don't we? So let's just get rid of one more. There.
Keep doing that. Keep doing that to clear everything.
Yeah.
Because you cannot take the card anymore.
Yeah. Now it's corrupted. I forgot B3, didn't I? Congratulations, you are awesome. Team B wins.
Are you cheating?
Kind of. I mean, we just put in the same card over and over again.
All right, cool. Thank you. So each team has a different strategy, which is very cool. And I also have my own different strategy as well. I don't say my implementation is the best, obviously. So just for your reference.
You just spent 3 days on it.
Yeah, I'm just spending like 20 minutes actually. So, which is not so beautiful. So let me run this fast. It is very close to what Team B did. All right, so this is a console and the player 1, what's your name? And so Nozomi is my wife. And yeah, and I just, they take a different route. I just specify row and column 1 by 1. So if I say 1, if I say 1, like that, so it's showing what's the card. And if I say like 4, it keep asking. I'm just checking if it's really 1 or 2. And if I try to pick up the same card, it said you already took it. So check down the card. So 1, 3. Oh, so I took the card. So already you get hard 1, spade 1. Good job. So Nozomi-san tried to do the same. 1, 3. And Ken already took it. So this is basically what I have done. So it's pretty similar, but the strategy is slightly different. So first of all, I created the card class. So I simply put in the card with so this is the set of the card name and level and value. So I put in my mind that I may want to use a different set of the card in the future. So I just put in the name of the game. So maybe we can do animal, we can do like the full set of the card, and I can just have the level to display, value to compare. And I also have the different class set game. So this is more like storing the record. So card is just a set of the card. The game is to storing the progression. So it has game ID and the level, value, and it's a row number, column number, and the player to monitor the record who took this card and if it's taken or not. And in the service, I simply returning the card for ace 1 to heart 5 at this moment by saying this is the level and this is the value. And I didn't specify name, so I just passed in the name. And I also creating the games from the card because I have 10 cards and I do the random to placing the card in a random manner for the row and the columns. And in the main program, this is exactly same what I did in the team B. I was asking, first of all, I saying the showing welcome method with the UTF-8 output encoding, otherwise the hard mark will be garbage. And player 1 what's your name, player 2 what's your name, to storing the name. And after that, I just calling the play while completed is completed. In the game, I just say the row picked, column picked, and the row number, column number. And I just keep checking if the player putting the row number in the correct way. So I put 1, 2 at the list to say index O to try to find if that's really the one, or even before that, I try to pass to the int so that it failed. It's going back to the loop. So I pick up the correct number, row, and the columns. And now I can pick up the card. If the card is taken, I'm just showing the card was took by somebody. If it's took by you, I said you, otherwise put your name. Otherwise, I mark this card was taken by the player. Even though this is the first card, I just mark it as a true. And the card was taken by this player, so that when I pick up the second card, I can verify it's already taken by me or other guy. And I also put the card turn, if this is the first card or second card, by checking the first game, the value. Then the first card is something or the second card is something. If first game is no, meaning this is the first card, so I'm storing the game as a cache. And if this is the second card, I check in the value to match. If it's match, I force the taken to be true. Actually, I don't have to do this because it's already true. But anyway, I just did that. And I said, you got this one and that one. Then I'm just checking if the games which taken with the count is equal to 10. Actually, I can just say games count other than hard coding 10. Then I said that's the end of the game. Otherwise, I just reset everything back. And I just mention you pick this one, that one, which is not much, and reset everything back again. All right, so that's a kind of dumb logic. But the interesting part is every team A, team B, team can doing the different implementation. And obviously we study each other from the different perspective, I hope. Did you enjoy?
Yes.
All right, that's the most important part. All right, so that's the end of this month meetup, and the next month will be again 3rd Tuesday, I hope. Which day is that? 3rd Tuesday, February. Does anybody have the?
20th.
The plan on us? That should be 19th. 19th.
Yeah. 19th.
19th. So the next one maybe February 19th or the week after. Definitely not the week before. So the 19th February might be the next day, and we welcome you to be a speaker. And if you enjoy this kind of the coding challenge as a team, we can put another challenge with so I just wait your feedback. Anyway, thanks for coming, and I just need to take a picture of the group, so please come in front. All right, goodbye, YouTube.